Good afternoon, pilot teachers and students. Good afternoon, class.
Good afternoon, Mr.
All right, thank you. You may sit down. All right, in our last lessons, we went through basically studying electricity. And you found out that when electricity or electric current passes through a conductor, it must do work. And since it has to do work, it must have some form of energy. And this energy is known as what is this energy known as? Failing. All right, we know that when electricity passes through a conductor, it must do work. Okay, when it does work, we know that it has some form of energy. Okay, this energy is known as right, joule is the unit of the energy, but this energy is known as, okay, good, electrical energy. Now we will also go through and then measure power. What is power? Kimberly. Okay, Kimberly Sierra, you tell us what is power.
Energy used per second. Energy used per second.
Okay, my question is power. Okay, I'm asking about power. What is power? Energy used per second. Okay, it is the amount of energy that is used in a second. Or we can simply say power is the rate of doing work. Okay, when work is done, you have rate. So the rate at which this work is done is known as power. So when we are talking about rate, we simply mean the time that is given or the time that is taken for the work to be done. So looking at power, power is simply the rate of doing work. It can be in joule per second. Okay, 1 watt is simply equal to 1 joule per second, or it can be in kilowatt. 1 kilowatt is equal to 1 kilojoule per hour. All right, those are some units of power. All right, moving on to the flow of current can be used to do work, and the flow has that energy. Now, we call this as electrical energy. However, the rate at which the work is done is called power. All right, you can go through quickly and then copy that information, including the definition. But I will give you 1 or 2 more slides from here, and then after that there will be 2 questions. Okay. We will move on now. Right, if you want to calculate the power, okay, that is simply the rate at which the work is done. You can use that equation or formula, P equals to E over T. What does E stand for? Okay, it is for the right, probably when you go through in the past lessons, you may have seen that power equals to, okay, the work over time, and that is energy over time, which is equals to Q times V, which is equals to that, which is I times T times V. So when you have to bring this one over, right, so you simply have power which is equals to I times V. So it can be 1 watt equals to 1 MV. Or you can have it as equals to 1 joule per K. All right, we have to look at this. This one is for that equation, power equals to current times voltage. So we have 1 watt equals to 1 volt, okay, 1 amp volt. For this one, okay, power equals to work over the time. Right, for example, you have to see the work that is done. All right, that the light energy that is given from those fluorescent tubes. The fan, when it is spinning, it has some kind of kinetic energy, okay, meaning that energy is not created or destroyed, but it is, okay, transformed. It is converted to other forms. Okay. All right, for this, watt equals, so power equals to current times volt, or ampere times volt. So you have this one as 1 watt, which is equals to 1 amp volt. So that means a voltage has been given to each amp. In here, it shows you that, okay, 1 watt is simply the amount of energy supplied every second. All right, you will decide to include the resistors, or in a circuit you find that there are different types of resistors in a circuit. Then you can use that formula to solve for the power. All right, simply for this, power equals to I times V, but when you have 2 resistors or resistors in a circuit as well with the power and current, then you can substitute this formula. Right, how did we arrive at the formula? Right, simply power equals to I times V. But if you decide to have the resistors as well, okay, you can use this, which is equals to, if that is not given, and you were given resistor and current, then you can use this. Power equals to I times V, and then when you have to substitute this V, which is equals to I times R. Okay, for this V in Ohm's law, V equals to I times R. That is why we can come up with I square times R. Or if you were given R, then you can have I times K R, which is equals to V over K. I equals to V over R. So that is why when you have to use this, that will be I times V over R. And then you come up with I times V square over R. All right, you quickly copy this, the first one for power, and then I'll go through the explanation of that. You finish. Right, for the energy, you can use the same. E equals to I times V times T, right, which is equals to okay, I square times all right, for this you are simply taking that as I times V equals to IR times T, so we arrive with I square times R times T. Or it can be the other way, which is using that, then you have I times All right, you finished with that? Okay, I will give you the activity questions. That is question number 1. Question 2 has 3 parts to it. So quickly copy question 1. I'll show you question 2, part A, B, and C, and then you can complete those. All right, question number 2. All right, an electric kettle is connected to 40-volt supply and it throws a current of 10 amps. Calculate A, the power of the kettle, and then B will be to calculate the energy produced in 20 seconds. Okay, I'll give you question C or question 2. Okay, here is the last question to part 2. Okay, the rise in temperature if all the energy is given to 2 kilograms of water. Right, to calculate the heat energy, especially in water, you can use the specific heat capacity of water, which is 4,200, and then you have this one as the mass times the change in temperature. Temperature can be in degrees Celsius, or it can be in degree Kelvin, or it can be in Kelvin or degree Celsius. Question 1. Did it do one yesterday? Okay, 1, 2. You'll be question 1, 2A, 2B, and last question will be 2C. Chose 2C. First question, is it 2A? Yep. 2C. 2B. Okay, we will go through the correction to those questions. All right, question number 1. Those students who asked to the question 1, question 2, A, B, and C, all right, you get ready with your answers. As soon as the first person goes up, right, you get ready. All right, so the pilot students, please observe carefully as the model students will show you the answers to those questions or the activity questions, and then you can verify or check with your own answers. So for question number 1, we'll have Rachel.
Since the question is asking us to find power, the formula for power is current times voltage. The current is 4 amps and the voltage is 12 volts, so my answer is 48 watts.
Right, can you find something wrong with this? All right, the answer is quite correct, but as long as you, all right, this one should be, yeah, okay. 48 watts is correct. All right, we'll have the second mission. Well, yeah, yes. That is for the mention, 4,200. That is specific heat capacity of water. Yeah, specific heat capacity of water. Yeah. Mass and change in temperature. Change in temperature. For this time you were asked to find that temperature. In other words, you were asked to find the heat.
Power is equal to current times voltage. The current was 10 amps and the voltage was 240 amps, so my power was 2,400 watts.
Okay, check your answers. Is that correct? Yes. All right. B.
Since we already got 2,400 as the power, and we asked to find how much energy is used in 20 seconds, we simply multiply the power by the time. The power is joules per second, so that's in 1 second, this is the amount of energy used, times 20 seconds, the seconds will cancel out, and joules remain, and it's 20 times 2,400 will give us 48,000 joules, or 48 kilojoules.
Okay, is that answer correct? Okay, yes. Right, the answer is 48,000 joules or 48 kilojoule. All right, the last question, Jos. Just move.
It takes 4.2 kilojoules to raise the temperature of 1 kg of water. By 1 degree Celsius, it takes 4.2 times 2 to find the temperature of the water. 48 is the energy, and therefore the temperature is 5.71 degrees Celsius.
Right, good. The answer would be 5.71 degrees Celsius. So that is the amount of heat that was given to the water, 2 kilograms of water. Right, quickly to recap on what we went through in the lesson, right, especially when electricity has to flow through a conductor, or let's say when the current has to pass through, it must do work. And that work, in order for that work to be done, must have some form of energy. And we know that it is electrical energy. Now, if you want to measure the rate at which this work is done, then we are trying to measure the power, okay, how much power is supplied. So using those equations or the formulas, you can calculate or solve the power that is supplied to each one of those appliances or the components. So using that equation, which is equal to, or power which is equal to current times the voltage. But sometimes you are given for combination of resistors in a circuit, then you can use other equations which may also give you the power in watt. Or if you want to calculate the energy, right, you can also use the other equation instead of using current times time times V. Right, so that brings us to the end of the lesson. Our keyword for today would be power. Good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon. All right, thank you. You may sit down.